This is circuit number 1. You'll set this up in LTspice, and when you have the schematic of LTspice, schematic in LTspice, you will simply copy and paste that right here. Okay, right where it says, you know, insert circuit. You'll just put it right there. And if it takes more space and if other things move it to the next page, fine, just go with it, right? They don't have to be all fitting in one page or something like that. In fact, make it large enough so that it looks like it's readable. Okay, and then the waveforms after the simulation, you'll put into the waveform section, insert waveforms, copy and paste the graphic basically, and then you'll fill out the columns, appropriate columns corresponding to the intermediate variables and the output variables, just like we've done by hand in the lectures. Okay. And once you fill these out, you're done with circuit 1. You go to circuit 2. So there are two circuits with there are two inputs, right? So A and B are inputs. Therefore, your truth tables and your outputs are going to have 4 rows, right? And then there are some 3 input circuits. There's 2 of these, and these will have 8 rows. And everything is there. All you have to do is set up the circuit, run the simulation, copy and paste schematic and waveforms, and fill out the columns. So it's once you do one, the rest should go, I think, pretty quickly, I think. So I'll send you this. That'll be up on Blackboard as well. So you don't have to worry about what the formatting is. I'm giving you the formatting. You just fill the information in, and that's it. So I hope that makes that part of it easier. Okay. All right. So how do the how do the circuits how are they entered into LTspice, and what do we need? So to do that, I actually have some examples. Okay, so I have like a 2-input example and a 3-input example to show you. So here's my 2-input example, and I'll show you the complete thing. You know, how you get the waveform, how you copy and paste it in, etc. Okay, so to make it easier, I've already set up the waveforms for you, as we discussed in lecture. Like if you have a 2-input circuit with inputs A and B, you need to have 4 rows, right? You need to have 4 rows, 0, 0, 0, 1, 1, 0, 1, 1. We discussed that. And of course, we can set up a waveform A and B going from left to right that goes through these 4 combinations. And the waveforms shown do exactly that, right? So if you go from left to right, you'll see 0, 0, 0, 1, 1, 0, 1, 1. So that should be pretty clear, right? So how do we set up these waveforms in LTspice? Well, I've already done that. Don't have to worry about that. In fact, they're shown on the circuit in the left, right? We're in LTspice there, and I'll give you that. So I'll give you this starting point. In fact, let me simulate it to show you what happens. So if we just say run, okay, and I'll start from scratch. Okay, I'll start from scratch. If you have this, and if I just say run, what do you get? Okay, well, you get the schematic window that opens up. Okay, if you go on the schematic itself and click on that, make sure that that window is chosen, and if you probe A and B, right, you'll get the waveforms. Okay, but they might look like this. Well, you know, how do I make this clear? Well, you can open up a new waveform pane, P-A-N-E. Not P-A-I-N. But if you take your cursor and you right click, it'll say add plot pane. If you add plot pane, you get a new graph window opening up, and then you could take one of these waveforms, A or B, and move them up. Let's move A up, okay? So let me go and left click and drag up, and you'll get the waveforms A and B. Now those waveforms look exactly like what we need on the waveforms as shown on the input example to the right. So now we have the waveforms, okay, A and B. Now we haven't set up the circuit yet, but we have the waveforms, okay. Now let's go back to the schematic. If you go back to the schematic, you see that on the right, I have already put up in the schematic the 3 kinds of gates that you'll need: the AND gate, OR gate, and the NOT gate. Okay, in fact, the AND gate and the OR gate already have the different kind of outputs, right? So you can use this gate either as an AND gate if you use the top, or if you use the bottom with the bubble, you can make it a NAND gate. Same thing with the circuit A2, right? You can use it as a NOR gate or a OR gate or a NOR gate. The bottom is simply a NOT gate, okay? Furthermore, these extra squares on the left, right? So you can use this as a 2-input AND gate, 3-input AND gate, 4-input AND gate, 5-input AND gate. So you can use them as multiple inputs. The question is, how do we put bubbles in the input? Like, for example, if you look at the first gate here that has A, B as inputs and D as output, there's a bubble over here. Well, how do I make that input bubbled? Well, in this case, you'll have to use a NOT gate, and that's why I have A3. So if you start from this point, this circuit here, you can copy and paste and make duplicates of gates to make it look exactly like what you need to make it look like. And if you don't use a gate, you can leave it there and it will cause you no harm, basically. So right now, even though I simulated the circuit, I didn't hook anything up and that was just fine, right? All right, so let's design or let's put together the circuit. Now, it might help you to know how to copy and paste things and move things around. Like, for example, let's say I want to make a duplicate of this AND gate, which I can also use as a NAND gate, right? How do I make copies of this? Well, I can use the copy command. The copy command is called duplicate. So if you go to the edit command here, you see that the shortcuts of everything is pretty much given, right? So if you want to make a copy or a duplicate, you can use F6. You want to move something, F7. Drag, F8, right? Remember, drag is where if you have wires, it'll kind of stretch the wires. I've talked about this before in my other videos for experiments 3 and afterwards. So let me just move first. Okay, let's just use move. I can take this and move it around anywhere I like. If I take it and let's say move it somewhere here, I think that should be just fine. Maybe right here. And then maybe I want to generate that bubble. How do I generate the bubble? Well, I can generate it by using the this gate down here, right? So let me move that, okay, and put it right there. So now I'm in position to wire things up. How do you wire things up? Well, you can go to wire, or if you remember from the edit command, if you look down, there's F3, right? So you can simply use F3, or you can click the wire. It's up to you. If you're on Mac, I believe there's a little pencil icon at the top by the menu item, right? If you don't see something there, if you right-click, the context menu will give it to you. Okay, let's just click here and just go through on wire, okay, and you can just go straight through, and there you go. Now I made my first connection. How about B? Okay, well, I can copy that too. Oh, sorry, I can wire that too. I can go like this, move here, and move up here, and maybe move a little further up, or maybe move a little further down. It depends on how you want to wire it exactly. Maybe I want to wire it maybe right down here. Okay, there you go. Okay, now let's say you want to move this T rise up. How do you move that? Well, you can use the move command. You can use the move command and move these little things up and down as you wish. Okay, just don't erase them. So now we have the we've just generated one of them, right? One of these things. Okay, now if we're done moving, right click and we're back to the normal cursor. Right? So I hope everybody is with me so far. Okay. Now let's do the bottom one. Okay, in the bottom one, bottom OR gate here, the NOR gate, what we'll do is this. We'll take the move. Okay, so we'll get the move over here. Okay, so we'll click on move. And maybe bring it somewhere over here. Okay, and now we need another NOT gate. Let's duplicate. Okay, notice the cursor changes into the copy, and once you click on that, you're able to move a copy of it down here, right? And now you realize, hey, these rise things just kind of getting in the way. Okay, so let me get out of the copy mode by right-clicking. So I'm out of the copy mode. You can move those around, right? And remember, after a while, these commands, move, drag, F7, F8, it's going to be pretty simple for you. I actually am using the menu items up here because my keyboard F7, F8, I'm using it for something else. So let me, but if you type F7, right? If you type F7, you should get the move and the drag. Let's just use the move and just move these down. Okay, let's move it down and move it down like this. Okay, now I'm ready. So I want to take B. If you look at the picture, I want to do B and I want to do a prime, right? So here's B and I negated it and I go down, and so I have that, right? And then I had to bring down A. Okay, how do I bring down A? Well, okay, so I get this. I click somewhere on A, and then I just drag through, and then right there, okay? You might have to play around with this a little bit, but should be no problem. So anytime the wires cross, right, I mean, they're not touching. Unless you see a square dot, there's no connection there. So this kind of completes the left-hand side of the waveform, or the schematic, I'm sorry, okay? But we'll continue on to the right, okay? Just notice that we'll need another AND gate. Where do I get another AND gate from? Well, I can just copy from here. So if I just go copy and click on A1, I can get my AND gate, okay? So now I have to maybe, again, right-click to get out of the copy mode. Let me make this window a little bigger so you can see it. Okay. So now what am I going to do? Well, this AND gate, the final AND gate, has two inputs, right? One of them comes from the AND output over here, right? So I'll take that and maybe put it right here. I can put the input, I can use any of the 5 inputs, right, on this. There's no restriction. I can use anything here. But the bottom gate, right? Bottom gate, I have to first negate it, right? So in other words, I have to use the NOR output here. So wire it, right? Wire, and then go here, and then maybe go here, and do that. And now I have my output, right? The knotted output. So I hope you can see how it's done. It's not that difficult. It'll take a little bit of time to do the first one, but then it'll get easier. It'll get easier. And then so when you have this, right, you're almost done. But maybe I want to do a few adjustments. For example, the final output I'm going to take over here, right? And now I'm pretty much ready. Now what I'm gonna do is I'm gonna save this as a different file, right? I'll give you the starting files where you have the AB sources and then your AND gate, OR gate, and the NOT gate. I'll give you all that, okay? But then when you save it as your file, okay, save it as your experiment 8x circuit number 1. Call it something else. So I'm gonna say save as, for example, and what I'll do is I'll just save it as, I'll say sample for 2 input, right? So I'll save it as that. So that I won't, that means that I can go back up. I can open my template again. So my template looks like this, right? My template looks like this. This is where I started from. So I can start with this for the next one too. Or you could start from, you could start from this circuit and copy around, right? Because the components you need are all here. There's 3 different components you have, okay? You have the NOT gate, you have the AND gate, and you have the OR gate. And of course, with the AND and the OR, you have their NOR options if you use the bubbled output, okay? Besides that, you have the sources AB already done. you don't have to really touch A and B at all. You can just use them as is. Okay, now the only other thing that I can do here is that, just to make things simple, I can go to, like, if you look at the picture, the 2 input example shown right here on the right on the PDF file, and my circuit, maybe it might help me if I label those outputs as D, E, and Y and shown. That's very easy to do as well. I'll show you how to do that, and I think most of you know how to do that. Okay, so what you do is you just take your cursor and go to that node, and if you look on the lower left, it says this is node N002. If you right click, it'll just say label net, right? Label net, and so you can go and label that as, for example, D. And when you say OK, a little D with a square comes up, and you'll just place it exactly where you need it. For example, right here, left click and you're done, and then right click to get out of that mode. Okay, same thing with this node down here at the output of the NOR, right? Right click, label net, call that E, OK it, place it, and right click to get out. And again, when you're in these modes, like for example, you're saying move, right? And it changes to this hand. After you move things, when you're done, right click, gets out of the mode, gets out of that mode, and you're back to the normal, cursor, the plus, the cross. Okay, the final output, again, right click, label net, Y, you OK it, you place it here, right click, you're done, and I save again. I'm good to go now. I can just simulate. Everything is there for you. Simulation command is there already. Transient. It's going to run analysis for 5 seconds. It's there. All you got to do is basically hit the running man, and after you hit the running man, right, you'll have your waveforms ready, except that you'll have to click on them to actually view them, okay? So let me do that now. Let me make this window bigger so you can see more of the action, okay? So here we go. If you click on the tile windows, you can see both the circuit and the simulation at the same time. So now I want to see, for example, so you can select the waveform window, or you can select the simulation window, right? So as you do that, something else highlights, right? So with the simulation window chosen, if you go near a terminal like D, it turns into a probe, left click, and it shows the simulation, right? If you go to E, a click, it shows the simulation. Okay, the waveform basically, sorry. If you go to Y, click, it shows the result. The only thing is they're all on top of each other. So if you want to see this nicely, we'll have to generate new waveform pane. So right click, add plot pane, right click, add plot pane, right click, add plot pane. I generated 5 because there's 2 inputs, right? There's A and B, and there's 3 outputs, D, E, and Y, right? So by just going on the waveform and dragging, right? So I'm just going to the, I'm going to B, right? I'm just dragging it up, right? So you can go to B and drag it up over here. So I'm seeing A and B at the top. Then I want to see D, for example, and E, and then maybe Y I'll have down here, right? You might see some funny things like little spikes or here like that. Whatever you see, just kind of go with it. Don't worry about it. You might see some, I'm sure you're seeing these little things on the. Those are just simulation artifacts because we're trying to run an ideal simulation. Don't really worry about those. Just report what's here, and you'll be good. Okay, whatever you see, just report it as is. So now you're done with the first circuit. Now, how do we get these results to your report? Well, here's how easy it is. Okay, so let me grab a sample report template. Okay, so we're kind of done with this first now. Let me grab the report, sample report. So this is not your report, but this is just a sample. Okay, where I have places to put the schematic and the waveforms. By the way, I'm here with my puppy, and for some reason she's not enjoying my simulation video. So she likes my lecture videos, but live lectures, but she doesn't like this recording. So she's huffing and puffing. That's what you're hearing. So, and then you're hearing people outside mowing their lawns. That's what you're hearing. Sorry, I can't filter those out at the moment. Anyway, okay. So how do we get these things into the report? Well, let's say this was your report and this was your circuit. I mean, you already did the circuit, right? How do you get the schematic from LTspice in there? Well, just use your favorite screen capture, or you can just use the tools within LTspice. If you go to Tools, copy bitmap to clipboard. On a Mac, you can just copy that window if you like. Anyway, it's fine. Copy bitmap to clipboard, right? That copies. You're in the LTspice simulation now. Just say paste. You're done. Okay. The simulation, the waveform window. Just go to the waveform window. Just say Tools. Copy the bitmap to clipboard. Come over here and paste. Okay, paste. You're done. And okay, maybe you want to move the circuit simulation waveform label down. You know, maybe click a few enters. Okay, I'm down here, and then simply go ahead and fill the D, E, and Y values here. And you can see, right? If you got the window here, if you have 0, 0 for A and B, what's D? It's 0. What's E? 0. What's Y? 0. So the D column will be 0, 0, 0, 0. Okay. What's the D, E, Y row would be 0, 0, 0. Okay. How about 0, 1? Okay. So here is A and B. A is in the second time period, right? A is 0, B is 1. What's the output? Well, everything is a 1. So the second row is going to be 1 for D, 1 for E, 1 for Y. Anyway, I think you get the point. Okay? It's pretty straightforward. Pretty straightforward. All right? I want to also show you an example for the 3 inputs. That doesn't really make any difference, right? It doesn't really make any difference. But for that one, I want to start with my template for the 3 input, and I'll give you these things. Okay, so you know what to start with. So let's say for the 3 inputs, I have a circuit like this. So let me move this to the side. Okay, for now, for the 3 input case, and let me go and show you the 3 input example that I'm going to do. Okay, so let's say we want to set up this circuit, and as you know, for the ABC inputs, we need waveforms as shown here, right? I talked about this in the lecture, so if you watch a lecture, you know this, right? And if you go from left to right, this goes through the rows that I need left to right. 0, 0, 0, 0, 0, 1, 0, 1, 0. It goes row by row all the way to 1, 1, 1. Well, I've already done that for you in the starting point for the 3 inputs, right? So here's the digital test for 3 inputs. These waveforms generate exactly those waveforms, and the simulation will run for 10 seconds, so you'll be able to see the 8 time intervals, which are all 1 second for simplicity. Okay, so let me run this. How does this look like? Okay, run it. Okay, and let me get rid of the other stuff that we've done. Okay, how does this look like? Okay, and let me make the window bigger so it's clear to see. Okay, here we go. So how do A, B, and C look like? So here's A, okay, here's B, and here's C. They're on top of each other, so I'm gonna add plot panes, right? Right click, add plot pane. Right click, add plot pane, and then take A on top, B in the middle, and C on the bottom, so you can see things clearly. So every 1 second, right? Something changes, right? One of the 3 waveforms change. So you have 0, 0, 0, 0, 0, 1, and so on and so forth. And after 8 seconds, everything repeats, right? So you only need to look at up to 8 seconds to determine rows 1 through 8. Then it repeats, okay? If you run the simulation for something more than 10 seconds, this will repeat. So I hope that's clear, right? So I'm going to give this to you. You can start from here. I'm also going to give you the sample files that I generated. You can use those as well. But starting from here will probably be the easiest, okay? Unless you want to move around and make sure you adjust things properly, right? So let's take a look, okay? So let's put together this circuit. Only 3 gates, right? So we have a 3-input NAND gate. We have a 3-input NOR gate, but one of the inputs is bubbled. Okay, we can do that with using a NOT gate at the input, like we did before, no problem. And then for both these inputs, so both these gates, right? I can take the outputs with the bubbles, right? So I can go to the bubbled outputs to generate the NAND and the NOR functions. And then finally at the output, I have a simple OR gate. And that's my 3-input example. Let's go through and do it, right? Let's go through and do it. All right, so I have a NAND, so I can just use this, right? So I can just leave it there or just maybe move it around a little bit. So I'll go to move, okay? And then just go and maybe somewhere over here, okay? Then I'll have my NOR, which will be right here, right? And for both of these, you know, I can simply use the knotted outputs or the I should say I can use the bubbled outputs, right? Same thing for this one, right? Wire it, and then when you're done, right click to get out of the wiring mode. Okay, so go through, left click, and then when you're done, right click to get out of the wiring mode. And then, you know, what else do I need? Well, I need an OR gate. How do I get that? Well, just copy, right? Or what LTspice also calls duplicate. So if I just duplicate this and come over here, for example, right? I have what I need, and I'll just have to wire these two outputs that I've just generated right here, okay, to the, you know, only use 2 inputs, and that makes it a 2-input OR gate, and the output will be from here, right? That'll be the output, what we call Y. Left click and right click to get out of the mode, and you're done. I can label these, right? I can label these, and I can say, okay, this is my what is that? That's D, right? For example, here's D. Okay, and place it right here. Right click to get out of the mode. This is gonna be my E, right? And always double check with the schematic to make sure you're implementing the right thing. And then this will be finally my Y, right? Label net, and this is my Y, my output. So my, you know, it's pretty straightforward. You know, the outputs are already generated. Now I have to wire up to the inputs. Okay, the only tricky one you could say is the one that you know, has the bubble here. So, and for that I have to put in my gate here, right? So I can just simply move it or drag it, doesn't matter, over here into this position, and I'll be ready. Okay, and each of these gates are gonna take 3 inputs. So you can do it any way you like. In fact, I can use, like I said, I can use any 3 of the 5 pins on the left of these AND gate and the OR gate, right? Or in this case, NAND and the NOR. I can generate any of these 3, or I can use any of these 3. Like for example, I can use this one, right? And then maybe like the middle one, and this one, right? Those will be my 3 inputs. Same thing with this one. I can do, for example, I can do this and this and this, for example. All I have left to do is to connect those to ABC. And I mean, one way of doing that would be I just, you know, take a wire, you know, like this, right? You know, I could do, here's A, right? And here's B. And here's C. Right? And then same thing for the one on the bottom, right? A could be like this, and maybe B could be like this, and maybe C could be like this, right? And I can double check, right? If I drag my cursor over the node, you can see it says click the point voltage at C, so I know I'm connected to C. Like if I go right here, that's sorry, I made a mistake. This should be B, right? And if I put on the note, it says C. So I should have gone up to the second point here. So let me fix that. Okay, so I caught my error. So this goes over here. Now it's correct. Okay, so A, and then B, and then C, right? So those are all good. And the top is A, right? B, C. I'm looking at the lower left to make sure I have those connected, and I'm basically done. I'm basically done. Now, there's another way to wire these, which will make things a little easier, okay, in terms of making mistakes and what I just did, right? I connected to the wrong point there. So if I undo all these things, and let me undo, okay, all these things, or I can just cut, start from the beginning, okay, like this. Let me go back to my original position to show you what I could have done. Okay, so let me just put these wires in. So let's say there was a wire here and a wire here. Okay, sorry, I didn't complete that wire. Okay, and let's say there was a wire, you know, here. I'm making them all the same length so you can see the consistency. Okay, so let's say I had this and I was going to wire ABC. Another way of doing the ABC wiring is this. Okay, if you name these wires ABC, there will be an invisible connection from wherever ABC is defined to that point. Now, what does that mean? Okay, so actually, if you just go and copy this A value and put it here, for example, you connected those 2 points together. There's an invisible connection between this A and this A. Okay, equivalently, I could just go and, you know, right click on this label and call it B, right? So you'd be very careful at calling nodes different names, right, or the same names. Look, so if you do this, right, there's an invisible connection between this B right here and this B right here. Okay, so you can just also copy the name, so you don't have to worry about, you know, writing exactly the same symbol or something. So now those are connected together, right? Similarly, you know, I can do the same thing for the bottom. I can say copy either this A or this A, doesn't matter, to down here, right? Copy this B over here. Copy the C down there. And actually, that's an equivalent wiring, actually, believe it or not, to what I just did before with physically connecting the wires. This is a little cleaner, so you can use this as well for this circuit as well as the circuit that I showed before, the 2-input example. You can use that. Okay, so I ask you to do that if you want to do that. Okay, you can try it out. It's very, very convenient. But now I have done this. Okay, so let me say save as. Okay, let's call it sample to input. Okay, sorry, not sample to input, sample 3 input, because 2 input we already did that one. Okay, sample 3 input, there you go. Okay, I mean, if you want, you could have some of the wires wired and some of the wires not wired. It's really up to you. So between the 2 examples, you can see both techniques. Okay, but now we can simulate this. Let's do that. Run the simulation. And of course, we just have ABC. We need to probe, right? So let me make this window bigger so that we can see how the other waveforms would look like. Okay, so we're interested in, for example, D and E and Y. And of course, I'm not saying these waveforms are very exciting, but this is what they're doing. Okay, so add plot pane, add the plot pane, and add the plot pane because we have 3. So here is A, right? Left click and drag. B, left click and drag. C, left click and drag. And then we have D, and then E, right? Left click drag and left click drag. That's what they look like. Not very exciting maybe, right? But this is what's happening. So what do we do to document this? I'll show you again, okay? I mean, let me bring my window along for Word, right? So for Word, this is the circuit that I built. Hopefully it's correct in the way I did it. It's an example, obviously, right? So I want to just make sure I have the whole window here and copy bitmap to clipboard, and then just come here and say paste, and I have that, and the waveform. The waveforms, right? So we have the waveforms here. I go to waveform window and the window, sorry, tools, bitmap to clipboard, right? I mean, if you have other ways of grabbing that the image itself, go ahead and do it. I'm just showing you what I'm doing through Windows. But if you have another way of grabbing the picture in the window, like using snip, I think it's called, go ahead and do that. No problem at all. Okay, and then paste here, and here's the window, and then fill out the columns, right? So you go time interval by time interval, right? Here 0, 0, 0, and then you get 1, 0, 1, right? And then put 1, 0, 1 at the first row, and so on and so forth. Very straightforward. So we have two input circuits, as I did before, and two of these circuits, two of the 3 input circuits, and document, and then save this, save it as a PDF, upload, you're done. Okay, so I hope you find this information useful. It looks like I went for about 40 minutes. It was supposed to be short, but I guess I'm trying to tell you as much information as I can. I hope you find the information useful. If you get stuck on it, please post on Piazza. I'll be able to help you out. But I think if you know your way around LTspice a little bit, with the template I gave you, it should not be too much of a task. So I thank you for your patience. This is not the way we want to conduct the labs, obviously, but at this point, we don't have too much choice. But either way, I think you should know how to simulate digital circuits with simulators. That is something you should know anyway. And the more you understand, the more you see how this is done, I think you'll find it more and more useful. So this is an important skill to have. And I'm trying to make it as simple as possible, so that you're not going into the directories looking for components and putting the characteristics in there or something. You'll have a simple point to begin with, and then you can just copy the components around and move them around as needed to make the simulation run. Okay, so with that, I hope you're staying safe. I hope you're doing productive work, and good luck with the simulation, and I think it'll go well for most of you. I don't think you should have many problems. If you do have problems, please put it on Piazza. Thanks very much. I hope to see you soon, or talk to you soon, or I guess you'll hear from me soon. With that, take care of yourselves. Bye-bye.